What if you could digitize a process by transforming it into an autonomous model that is resilient to problems, easy to model and scale? In this video, we delve into the proprietary language developed by Xautomata to digitize complex processes into simple models based on automata. What's inside an automaton? An automaton is a simple, finite-state machine. Such concept is easily described as a program which can evolve over time, modifying its state from a discrete and finite selection of states. This notion is represented with a simple diagram where the automaton receives an input and transitions to a new state based on a set of conditions decided beforehand. This concept is the building block for the Xautomata language. To understand the potential of our language, let's use a simple example that illustrates the core principles. In this example, we have a tube scenario with multiple lines and decisions to make. Let's examine the four key aspects of Xautomata language. The first is that time is explicitly given for each automaton. This diverges from standard finite-state machines and is crucial when multiple processes run in parallel with time dependencies. For example, an automaton can switch a traffic light as time passes. Second, the system is event-based. Time is not the only factor. Events also trigger automaton actions. Based on programmed conditions, an automaton may switch a traffic light early for an incoming person. Third is the ability to instantiate new automata. Each automaton has a specific task, but can create new automata to handle subtasks if needed to complete its job, like a station manager needing 2 new train conductors. The new automata run until their task is done, then are removed. This ensures resources are used only when required. The instantiation can repeat, even for newly created automata. Take the example of a train conductors, which may need an automata to check for pedestrian crossing, as railroad crossing, and so on. Allowing the automata network to grow as needed to solve a task, keeping the model as simple as possible. Fourth is collaboration. Each automaton evaluates conditions against data given from the environment, but also knows the state of all other automata. This collective information influences decisions, like an automaton coordinating a railroad crossing for approaching trains. For example, an automaton controls a railroad crossing and modifies the track direction for an approaching train. In this scenario, there is a second train that knows the position of all other trains and the state of the crossing. The second train decides accordingly in order to reach the crossing only when it is safe to do so. In summary, Xautomata leverages 4 key pillars: event-based actions, explicit time metrics, instantiating new automata, and automata collaboration. While this approach can model operational processes, it may be less clear how it digitalizes organizational processes. But if we view the train as commissions, the station manager as company policy, the traffic light as quality control, and the railroad crossing as departments, it is evident this model can be applied to any organizational process. Thank you for watching, and any further information can be found at xautomata.com.